Cosmic rays were discovered over 100 years ago, and we still don't know where they come from, how they are accelerated. It's a wide open question, probably one of the oldest questions in astronomy. And we may not have solved the whole problem, but we have identified at least one cosmic ray accelerator.
We've been able for the first time to pinpoint a likely source of the high energy neutrinos and the high energy cosmic rays that fill the universe. The object is a blazar, which is a kind of galaxy with a massive black hole at the center that's busy devouring matter and sending out jets of particles along its axis.
So what happened is that IceCube detected a very high energy neutrino coming somewhere in the cosmos. Within less than 1 minute, we reconstructed where it came from and then sent a telegram to all the other telescopes.
What we saw was that this particular blazar was in a highly active state by a number of independent instruments, and that includes measurements by the Fermi telescope in space and by high energy gamma ray telescopes like the MAGIC telescope.
It's not really an IceCube discovery. It's essential that several telescopes collaborated to make this discovery. No one telescope could have done this by themselves.
Gamma rays and neutrinos are very closely related. Whenever you accelerate particles to very high energies, you produce both neutrinos and gamma rays. So this coincidence that we see both here from the same direction really makes us sure that now we have pinpointed actually the source of this neutrino. In some sense, whenever we do neutrino astronomy, we also do multi-messenger astronomy.
Once we had this connection between the high energy alert event and the blazar, we wanted to go back and see if we had evidence of neutrinos coming from this object before. And what we found is that in a period of a few months, there was an excess of neutrinos from exactly this spot in the sky.
Not that there was one neutrino event that was seen together with lots of gamma rays coming from the source, or that this place historically has had a time where there were neutrino excesses, but the combination of those two and the fact that they come from the same place, that's what's very significant about this discovery.
The really fantastic thing about what's happened is that it demonstrates what IceCube was built to do. IceCube was built to launch the field of neutrino astronomy.
The National Science Foundation, some 15 years ago, decided that they were going to take the gamble of building this detector by transforming a cubic kilometer of natural ice in Antarctica under the South Pole into a particle detector. And so this was a gamble. There's no guarantee that we would see cosmic neutrinos. And so there was no guarantee that when we saw them we would be able to identify their sources. And so the surprising result is here we are, and the gamble paid off on both counts.